Thank you for coming on my speech. Let me move. I see so many of you here, so I'm really glad to see so many people. So I hope this speech will be useful for your games, for your projects, because the best way to learn is learning on someone else's mistakes. And like most developers, we made some mistakes, and I want to explain them to you, and also I want to give you some advices. How can you avoid making the same mistakes? Of course, those mistakes were not terrible, but I think they are worth mentioning because many developers make the same mistakes all over again. So we need to find some solutions which can be used by many developers. The title of this speech is Embarrassing Mistakes, a short story about AI in serious games. And I want to focus on the serious games part of it, because when you're making meaningful game like this one of mine, you need to be aware of certain types of problems that you will have. Of course, you will have many different types of problems, that's for sure, but some of them may be more dangerous than the others. And I want to give you some explanation and also give you some advices. But first, let me introduce myself again. My name is Radoslaw. You can call me Radek for short. I work for 11-bit Studios for about 8 years, and I am responsible for making AI for our games. So, of course, from designing point of view, our programmers, they are also making amazing job of implementing my and other designers' ideas. So if you find any mistake in our AI, you can blame it on me, because mostly I am responsible for making mistakes. And I want also say something about the context of this speech, because I will use 2 games as an example for this speech. And the first one is this war of mine. The second one is Frostpunk. And both of them, they are a little similar. When it comes to technology, because in both of them we are using behavior trees. They are very powerful. Of course, the implementation is totally different, because in this world of mine we have only few people on the same scene. Like player has control over up to 4 people, and we can have like additional few people which can be NPCs on some level. So we have a different implementation for Frostpunk. In Frostpunk we have hundreds of agents, and we can support up to thousands of them, so that's a huge number. And for gameplay reasons we limit our number of agents up to, I think, 700 or 800. So it's still a lot of agents, walking around, making decisions. So behavior trees, they are very powerful. You can use them for a few agents, you can use them for hundreds of agents, and everything still works fine. And for those who don't know what behavior is, behavior tree is a data structure that is evaluated from most important parts to less important parts. In this case, we have a print screen from our editor for making AI for Frostpunk, and this is just a part of this editor because it has a lot of boring controls, boring UI elements. This is like the main scene like we have in Photoshop. So here we have upside down tree, because in behavior trees, when we are making behavior trees, most of them, they have this vertical representation. You can also have, this is horizontal. You can also have vertical. In horizontal representation, like this one, we have this upside down tree, and we can assume that on the left side, we have 3 branches in here, in general. On the left side, this branch may be responsible for fighting with player. The middle one can be responsible for, I don't know, like chasing a player. And the right one is responsible for idle action, like walking around and doing nothing. So we want to execute this part first. If we see player. If we don't see player, we are looking for the player. And if we were if we are aware of player presence. If we're not, then we jump to this branch, so we execute this part of our behavior tree. So this is how it works in general. This is a very simple tree. Our trees in our games, they are extremely huge, so I chose the simplest one. So if you are more curious about how behavior tree work in more detailed explanation, you can go on Chris Simpson article on Gamma Sutra about behavior trees. You can type in Google Chris Simpson behavior trees for AI, and it should show you in top results his great article. It's still very basic knowledge, but I think it's worth knowing how behavior tree works, because they are used in like 90% of video games. So it's very commonly used technique, so it's good to know how they work. Let's go back to our implementation of behavior tree, and here you can see that something on the left side is blinking, and this blinking part is our debugger, and we use this debugger to show to AI designer, which was me, what our agent is thinking about. So here we have a print screen, video, when I can select any agent. Well, it's barely visible because we have a white cursor and we have a lot of snow around, but if I select anyone, I can see what this agent is thinking about. And this is very powerful, but it's not some revolutionary concept, because we can see the same debuggers in Unreal Engine, in Unity, so the idea is the same. So you can select agent and you see what this agent is thinking about. So let's go to types of mistakes, because I made, for the sake of this speech, two types of mistakes, two categories. And the first one is funny mistake. And funny mistake is when your NPCs are making when this is a bug in your game actually, but it looks funny, and if you're making your player laughing or at least smiling, we can consider this bug as funny one. And for some games like Borderlands, it can be even some extra feature. Why not? So if your game is about making your player laughing, well, having funny mistakes is a good idea. You can change them into features. Why not? And also we have annoying mistakes, and this is when developer has to spend a lot of time in order to find reproduction steps for certain bug and to fix it. Mostly we have like a few hours, okay, to fix bugs, but if some specific problem takes like 2 or 4 days to find the cause of it and to fix it, we can say that this is annoying for developer mostly. And this War of Mine is the first game that I want to use as an example for this presentation. And this War of Mine is a game about surviving, about fighting in war. But in opposite to most games, we don't fight as soldiers. We fight as civilians for food, for clean water, for medicines, and player has control over up to 5 people. And and those people, they live in shelter. This is just one of these city buildings, and we can improve this building by adding some, crafting some additional items. And also we can choose one character and go outside, and when we are outside we can find another NPCs, and we can have interactions with them, we can help them, we can kill them, and we also have to make very difficult decisions. Because, for example, we need medicines, we can find old couple, and they are harmless, they cannot defend themselves, so we can just steal items from them, like stealing some medicines. They will die without them, but if we don't do that, our people may die. So we have to make very, very difficult decisions, and every decision has consequences. If we will steal too many things from too many people, our people may get depressed because they are not happy about sacrificing other people to survive. So this War of Mine is an example of a meaningful game, and that's why that's why funny mistakes, they are very dangerous for a game like this one of mine. And when mistakes are funny, they can break immersion between your game and a player. So many players who play this one of mine, as we know, they are emotionally connected to this game. They have this strong immersion feeling. So because of that, we need to be aware to fix all funny mistakes first, before fixing even technical issues. And this is because players they have patience. They can forgive you a lot, especially if they like your game. If your game is good, well, they may forgive you having some problems with technical stuff, like, you know, some frame rate drops and stuff like that. But they will never forgive you if you will break this immersion. They will be angry at you. So you need to set your priorities when you have issues, and you will have a lot of them, certainly. So you need to fix, for games like this one of mine or Frostpunk, you need to fix funny mistakes before fixing technical issues. Otherwise, well, players may bring your game down because they will be angry when you destroy this immersion. So that is very important, and you need to be aware of this if you're making a meaningful game. And the camera issue is the first mistake that I want to explain. And this is not some random bug that just happened. This is fully intentional approach. But from perspective of time, I think this is a little mistake, maybe not some terrible disaster, but it's still some problematic, because in our game, in this one of mine, AI, which is this behavior tree, let me go back and I will show you this. Behavior tree like that is able to control our camera in this one of mine. So we have two places actually where which can control our camera movement. The first one is C++ code, and the second one is our AI system. And we have something about 3 or 5 action nodes. And by action node, I mean behavior tree action node. Again, if you're curious about those nodes, you can go and check out this Chris Simpson article. So if we have some problem with camera, we need to check two places, because initially, for example, sake of cinematics, we wanted to disable camera or to move camera somewhere. So we used behavior trees because it was like a quick patch to our existing code base, just to add some nodes. But in long term, we actually lost even days because of we have two places where things may go wrong. So this is how it looked like. On the left side, we have a movie when everything is okay. And on the right side, you can see that if I move my cursor to the most left side of the screen, nothing happens, because here on the right side, our camera is disabled by AI and is not enabled again because some mistake. Of course, this is just a reproduction of this problem, because everything is fixed and it was fixed before game release. So you will not find it, I hope so, in our current version of the game, but this is how it looked like in the past. So it can be pretty annoying. This time for players, but also it was annoying for us, because, as I said, we have two places instead of only one when camera may be bugged. And my advice for you is that you should limit your AI only to make decisions for your agents, nothing else. And I know that it may be sometimes very tempting to add this one extra feature to your behavior trees, this one extra feature, but you should resist. This is not a good way to make games. You need to limit your AI only to make decisions, what to do for your agents, nothing more. And when you need to think in long term, because sometimes you may think that, well, I can add this extra feature and save a few hours, and you may lose even days in long term. So you need to think in this long scope of time. And there is another, there is no player character. It's another type of problem, type of mistake that we made. Again, this is not a random bug. This is fully intentional approach, not some kind of disaster, but I think it could have been done better. It could have been made better. We should make it better. And this is because we don't have player controller system in this game. Everything, not only camera, but also your characters are controlled by AI. And we have very special node in our behavior tree. This is decorator node. And this is responsible for reading data from your devices, like a mouse, like a touch screen, like a gamepad. And we use in behavior trees those data to send agent to this place. So you can click someone, and AI tree actually reads this data and will send agent and do some action in this play. But since this is AI, it may make different decision. It may refuse listening to player. And it's not like AI in this world of mine is trying to take over the world. Well, I hope so. But it may refuse listening to player, and we can have problem. But why? Why, you can ask, why we don't have this separation between player system and AI system? This is because at that time our mindset was, since we have this duality of movement, because in one hand your character may be controlled by a player. In the other hand, it can be controlled by our AI system. If you select some character in your shelter, in this home where those people live, you can just make some orders for this character. But if you unselect this character, it starts making its own decision, doing its own actions. It is controlled by AI. So yeah, we have this duality of movement. In one hand, it can be controlled by a player. In the other hand, it can be controlled by AI system. So we made a decision to merge those systems into behavior trees. Now, from perspective of time, I think it was not the best idea. It was also not the worst. But I want to. Oops, we have some technical issues. I think I pressed wrong button. Oops. Oh, yeah, exactly. AI is attacking. So, how it should have been made? You may ask. Well, we should have, obviously, two separate systems. One should be responsible only for controlling player character, and the other one should be responsible for player actions. So if we select some character, we should have AI off and player controller system on. When we unselect some character, then AI is on and player controller system is off. So we have two systems, but only one can be active at the time. And this is how it should have been made. And yeah, let's go to another one. This time we have smoking children problem. And this is because when I was making children behaviors for this world of mine, initially I just duplicated adult behaviors because they were pretty good. And I removed all adultish behaviors like drinking alcohol, but I forgot to remove one small branch of this tree. And this branch was responsible for asking for cigarettes. So this is how it looks like. We have like small 6-year-old girl asking, where are my cigarettes? And you can imagine that you have in this shelter some people dying from starvation, from hunger. Someone else is dying from illness, and this girl is asking about her cigarettes. This is just too ridiculous. So in my opinion, this is a good example of a game-breaking problem. So, unfortunately, I cannot give you, and just to be honest, this is just a reproduction of this problem. It is no longer in our game. You will not find it in your Steam version of this War of Mine. And unfortunately, I have no solution for you this time, because this type of mistakes, these types of problems, they are very contextual. They base on our cultural stereotypes. And because of that, they cannot be addressed just by setting up some unit integration tests or other automatic checking process for bugs. They cannot. You need to play your game. And what's even more important, you need to allow other people to play your game. So, in our case, we invited a lot of people from outside of our company, and we call this procedure, and maybe other developers also, focus test. So you invite people from outside of your company because they have this fresh eye. People in your team, they may be too used to play this game, and because of that, they may overlook some contextual problems. But people from outside, they are able to spot those mistakes. So I think it's the best idea to just invite people from outside and play your game, okay? Because this is important. And Frostpunk is the second game that I want to use as an example. And this game is a little similar to this War of Mine. In Frostpunk, we also have some group of people, but this time we have hundreds of them. But we start at least the initial scenario with just like 70 people or 100. And in Frostpunk, we have like global winter, and the temperature goes down very, very low, and our generator is the only building which keeps the city running. And generator is running on coal. It is burning coal and producing heat for your city. And also you have like the last city on the earth, so you are the last mankind resort. If you fail, humanity will be doomed. And also you have to make very difficult decisions. For example, if you are running out of coal, you may make a decision to send children to work at coal mine, some building, and this is very dangerous for children. They will die in accident. People will be unhappy, but you will have your coal and you will keep the city running. In the other hand, you may build a kid shelter for those children and let them stay in a safe place, but you still have this coal shortage. People may be happy because their children are not exposed on those dangerous situations in a coal mine, but you have a coal shortage and your city may fall because of that. So you need not only to make difficult decisions, but also you need to deal with consequences. And luckily, Frostpunk was made after this War of Mine, so we have actually know-how, experience, how to work with behavior trees and how to work with AI in general. And because of that, we were able to avoid making these mistaken approaches, like the camera issue. We only had funny mistakes, which actually is a good thing. If you only have, the only mistakes that you have related to AI are funny mistakes, that's good, because they are the only mistakes which are unavoidable. They will appear in your game, no matter what. So if you only have them, that's pretty good idea. I mean, not idea, but that's a good sign for you. And considering how many agents we have, as I said, we have hundreds of agents making thousands of decisions every single minute in this game. Everything is running pretty good, and that's a huge difference between having and not having experience how to make AI. So, Children Fight Club is the first example of funny mistake in Frostpunk. So this is a little similar to smoking children syndrome from This War of Mine, and this is because when I was making new behaviors for Frostpunk, I again forgot to exclude children from being able to join and fight in fighting arena. They can fight against adults, against other children. So, well, it's not the best idea to have this controversial behavior. And this is how it looked like. So we can see two children fighting against each other and some adults cheering them up. And but don't worry, no child was harmed during this production process of this game, because they cannot reach each other. And this is because animations were designed for adults, not for children. Children are not supposed to be in this place. And it was like a quick fix to make, because I just exclude children from being able to join this arena. And yeah, that makes sense. And artificial prostitutes is another example of mistakes that we have. And this is because automatons at some point were able to join and work as prostitutes. You know, you can imagine that having 80 meters piece of steampunkish metal working as a prostitute in your public house. And what's even more funny, when automaton is working as prostitute, human prostitutes, they lose their job. So everyone is everyone is angry, everyone is unhappy, and this is not a good situation. Again, I forgot to exclude automatons from working in public house, and this is how automaton behaves when it realizes it is working in public house as prostitute. So, well, it is trying to escape just under the ground. And actually, to be serious, this is our debug animation of dismantle, which we play if AI system realize that something is incorrect. In this case, automaton doesn't have working animation for public house, obviously, because, well, I cannot imagine that, you know, prostitute animation for automaton. So we play our debug animation, and this is because, as I said, automatons are too big to go inside of buildings. So when automatons can work, I mean, if automaton can work somewhere in some building, then we have animation of climbing on this building. So automaton is going on top of some building and it works as extension. So it can release people from working in this building. You can use those manpower in some other place. And obviously, public house doesn't have this animation, and AI system realized that, so it started playing this debug animation. And this is my advice for you. You can use those debug animations to indicate for your quality assurance department that something is incorrect, that we have a problem. And of course, you may say, well, I can print those problems as messages on my console, and after game I can analyze my console. Well, maybe you can, but not in our case. As I said, we have hundreds of agents making thousands of decisions which produce gigabytes every single minute, like few gigabytes of debug data. And this is because in our case, times matter. We have a capacity of some limit of this debug data, and it lasts for 5 minutes of real time. So if we have some problem and we wait like 10 minutes, debug data about this problem will be replaced with new information. So after a few minutes, we start losing our debug data about this problem. So we need to pause the game as soon as possible. So to do that, we need to show some visual indicator of problem. And also, we have three steps of verification in general, which can you also use in your game. The first one is AI designer, so the second one is test cases, and the third one is long run. So AI designer is a person who is responsible for designing AI behaviors, AI systems, tools, and everything AI related in your game. And also, this person should predict where this game may be broken, which situations may go wrong. So the more experienced AI designer you have, the more errors this person can predict. So if you have a list of possible places where things may go wrong, where some bugs may appear, then you go to the second step, which is test cases. And test case is just a procedure that needs to be executed, and after making this procedure, you have some expected result. For example, we want to check if automaton is working in coal mine. So our steps of reproduction for this situation is hire automaton in this building, wait a few minutes so it can go to this building, it can reach its destination, play attaching animation, and start gathering new resources. So our reproduction steps, make those steps, and expected result is that automaton should make new resources for you. And if our QA department see something else, like anything else, than expected result, for example, we don't have this animation, or resources are not gathered by automaton, then that means we have a problem in this specific situation. As you can see, we have 12.95, which is not the end of our test cases. We have hundreds of them. And because of that, test cases are very expensive to make them. They take like 2 days in general to go through all test cases by our QA department. So we can execute those test cases only before major releases or after some major changes in our system. But they are very, very accurate, only if you have someone who can predict those situations, because you need to know in which places you can expect having some problems. Yeah, so the third step of verification for your AI is long run, and this is when you allow people from outside of your company to play your game. And this is because, as I said before, people in your team, they are too used to play your game. They may overlook some problems, and that's why you allow people from outside of your company to play this game. And obviously, also your QA team is playing this game however they want, without any procedures, without any limitation. They can do whatever they want. So in this way, you can find possible edge cases, which cannot be predicted even by the most experienced AI designer. So this is example of another sort of problematic situations, because this is new map layout, and you can see on this map a lot of those bridges. They are very narrow passages for our NPCs, and initially our AI system was not designed to work with this type of landscape. Initially we had very flat surface, so this is how it looked like initially. You can see that some agents are trying to fit on this bridge, but some of them are levitating because they don't respect new rules. Yeah, yeah. So they simply don't respect those rules. So we had to adapt our AI system, our navigation system, to work with new ideas. And obviously, those ideas, I love them. Our designers are making a really great job providing new content for players, but they also provide some difficult situations for AI department. So we had to adapt our system so it will fit to new rules, to new content. So this is my advice. You need, when you are planning adding new features for your game, especially if your game is very successful, you may be sure that your design department will create a lot of new content, a lot of new mechanics, and you need to adapt your existing systems to support those mechanics, because probably if your game is successful, that means you have great designers and they will create wonderful content, but you need to support this content so players may enjoy this game, this content, and that's why you need to plan additional time for your AI department so they can adapt those systems to properly support those features. And also you need to create new test cases, for example, to check out those new situations which can go wrong. Let's summarize this speech. So the first thing is that you cannot avoid having embarrassing mistakes, like with smoking children syndrome. So you need to create a filter which will catch most or all problems that you can have in your game, like test cases, like focus test, like experience. This is also a tool that you can use. The second point is expansions may add unexpected complications. As I said before, you need to plan additional time for your AI department so they can adapt new mechanics. I mean, they can adapt AI mechanics for new systems, for new ideas. Smoking children syndrome is especially dangerous for immersion, so you need to play your game and you need to allow other people to play your game, because some of those funny mistakes, they are very contextual, and it's good to have opinions from different people about these problems. And use visual feedback for your QA department, because it is a way more efficient to have not only printing your errors on your console, but also showing visually that something is incorrect, so it may draw your QA department attention to this place, like with this automaton animation. We had a lot of more visual feedbacks for our, in-game visual feedback for our QA department. So it is, in my opinion, the most efficient way to debug your game. And don't forget to make a speech about your embarrassing mistakes, because me also like to learn from some other people's mistakes. And if you want to contact me, you can find me on my company email, or you can type my name on Google and find my LinkedIn profile. You can send me a message. But of course, the best way to contact is contacting with me personally, because I like speaking with you guys. And we also are looking for new people, because if you want to work with us, if you want to create this this meaningful gameplay, this something more than a game, we are trying to create experience. And if you want to work with us, we are hiring. Here we have positions for programmers, but you can go on our webpage, which is 11bitstudios.com/jobs, and you will find positions for artists, for designers. So again, we are looking for people, and we are looking for people who want to create meaningful gameplay.